Okay, so in this lesson, we're going to talk about part 4 of exponential functions, and this is going to be the last part of this lesson, of these sets of lessons. And in this particular case, though, we're talking about applications. And in the first application, the main one is called the compound interest formulas. And there are two compound interest formulas. There's this one, which is A equals P times 1 plus R over N raised to the NT. And then the other one is A equals P times E, and the exponent of E is RT. Okay, now let's talk more about these letters. So in this formula here, where you have A equals P times 1 plus R over N raised to NT, you're going to use this formula if your interest is being compounded a finite number of times a year. And you're going to use this formula, A equals P times E to the RT, if your interest is being compounded continuously. So you'll use the word continuously, which just means that the interest is earning interest at an infinite number of times per year. Okay, so P here in your formula, P stands for the principal. Okay, sometimes it's also referred to as the original amount. So how much did you invest? How much was the investment? How much was in there originally? So that's what the principal is. That's what P is. The rate is the interest rate. So it could be listed at 7%, 7.2%, 8.46%. But regardless of what the rate is, it's got to be listed as a decimal. So you don't write it as 4.6%. You got to change the percent to a decimal. And you learned how to do that in a previous course. N is the number of times being compounded per year. So that's what N is. So in other words, if your interest is being compounded quarterly, now what that means is that interest is earning interest 4 times a year. So that's what that means. So quarterly means 4 times a year. So every 3 months. Every 3 months. Semi-annually is every 6 months. So N would be 2 times a year. And then monthly would be 12 times a year. Okay, so quarterly means every 3 months. So that's 4 times a year. Semi-annually means every 6 months. So that's 2 times a year. And then monthly would be every month. So there are 12 months in a year. T is a number of years. So whether your interest is earning interest at 2 years or 3 years or 4 years, 7.6 years, but T must be in years. Okay, so T is a number of years, not the number of months, number of years. And A is the amount you end up with after that many years. Okay, so in the compound continuous formula, the letters mean the same thing. So A is the amount you end up with after T years, and P is your principal, how much was in there originally, how much you're investing, and then R is the interest rate, and the interest rate must be written as a decimal, not a percent. So you got to change a percent to a decimal. Okay? All right, so let's look at this one. So let's use this as an example. So use the compound interest formulas. All right. So find, so part A, find the accumulated value of an investment of, let's say, $20,000 for 6 years, at an interest rate of 4.5% if the money is, let's call this, I'm going to put these as A, so let's call this all right, let's be 1. So this is number 1. So use this. So okay, that'll be fine. So let's call this A. So if the money is compounded semi-annually. Okay, so here's what you got to do. So you're going to use, so semi-annually means that it's being compounded a finite number of times a year. So semi-annually means n equals 2. So twice a year, so every 6 months. So that's a finite number. So we're going to use this. It will say the words compounded continuously. If it says continuously, then this is the one you're going to use, because that's an infinite number of times per year that is being, the interest is being compounded. So here, interest is being compounded twice a year. This means that interest is earning interest on itself twice a year. Okay, so we're going to plug in what we know. So keep in mind that this $20,000 is your investment. That's what you invested. That's what you originally started out with. So that's your principal. So P is $20,000. Oops, $20,000. Okay, so that's what P is. T is 6. R is, now remember, 4.5%, you got to change that to a decimal. So let's remember how to do that. So to change a percent to a decimal, you move the decimal point 2 places to the left. Remember, percent means per 100. So divide by 100, so you can move the decimal place 2 places to the left. So the rate here would be 0.045. Okay? And then it's being compounded semi-annually, so that's in this 2. All right, so that's all we need to know. So let's find out how much this account's worth after 2 years. So A equals, so A is what we're looking for. The principal is $20,000, so 20,000 times 1 plus R, which is 0.045, divided by N, and N is 2, raised to the, now when you can put this in your calculator, it's very important you put NT in parentheses. If you don't put NT in parentheses and use your calculator without the exponent being in parentheses, you're going to get a wrong answer. Or you can verify by doing it both ways. They're not identical. So you need to put NT in parentheses. So N is 2, T is 6. So, I mean, 2 times 6 is 12, but sometimes it's not going to be that easy to figure out. I mean, some of these could be decimals, like 2.5 years and 6.5 years, things like that. Okay, but that's 12. But let's just leave it like this to show you what to do in your calculator when you do get a situation where it's not as easy to say 2 times 6 is 12. Okay, so in your calculator, you're going to say 20 times, in parentheses, you're going to say 1 plus 0.045 divided by 2, divided by 2, okay? So that was 20,000 times 1 plus 0.045 divided by 2, close the parentheses, raised to, in parentheses, even though it's 12, let's just do times 6, because you could have some decimals here. So 2 times 6, close the parentheses, and then press equal, and that's how much this account's worth after 6 years. So A would be approximately equal to, and it says to the nearest dollar, so to the nearest dollar. Nearest dollar. Oh, actually, I'm sorry, nearest cent. That's what it says. Okay, to the nearest cent. All right, to the nearest cent. So let's talk about that. What we mean by the nearest cent. Not the nearest dollar, but the nearest cent. Let me make sure. Yeah, nearest cent is what they want. All right, so the nearest cent. Okay. Now that. Okay. Let me go ahead and write down all this just to describe what the nearest cent is. 26120.9998. All right, that's going to be a little bit more difficult to talk about in terms of nearest cent, but we're going to have to deal with it. So to the nearest cent, that means the hundredths place. Okay, nearest cent means the hundredths place, like you're dealing with your own money. $5.46, $2.89. That's what we're talking about. So the nearest, so the hundredths, DREDTHS place. Okay, so that's the hundredths place. So that's going to be nearest cent. Now remember how you do this. You're going to look at the number right next to it. If that's 5 or bigger, you add 1 here. Well, the situation, that's a 9. So you're going to add 1, so that becomes 10. okay, then that becomes 10 itself. So you get this. So you're going to get 26120. Oops, sorry, 1.00. So you're going to end up getting $26,121.00. Okay. All right. So let's kind of talk more about the nearest cent. Let's round the nearest cent. So let me just kind of explain this. So if you had, let's say, 8.2654, all right, to the nearest cent, this becomes $8.27. Okay, if you have 7.26287 to the nearest cent, since this is less than 5, this stays a 6. So since this was 5 or bigger, this 6 became a 7. So to the nearest cent, this becomes 7.26. Okay, now that was a little bit harder because these were 9s, and so many students have trouble dealing with 9s. So nearest cent, so this 9's in the nearest is in the hundredths place, but we've got to look at the thousands place. Since that's 5 or bigger, I add 1 to the 9, I get 10. So 9 plus 1 is also a 10, so you get 0, 1, and you get $26,121.00. Okay? All right, B. Let's suppose it's being compounded quarterly. All right, quarterly. So in this case, N is 4. Okay, so every 3 months. Everything stays the same. So P is 20,000, T is 6, and R is 0.045. Okay, everything else stays the same. So we're going to get A equals 20,000 times 1 plus R, 0.045, divided by N, which is 4, and then raised to the 4 times 6 power, or 24. So in your calculator, let's see what we get. 20,000 times, in parentheses, 1 plus 0.045, oops, 0.045 divided by 4, close the parentheses. So 1.045 divided by 4, close the parentheses. Now you're going to raise it. And let's use parentheses because these could be decimals. This could be 4 point something and 6 point something. So let's just use parentheses. So, or no, obviously it's 24. So you could just say raise to the 24 power. Just leave it as we're doing it, just in case. I mean, you could end up with decimals. So in parentheses, you're going to say 4 times 6. Close the parentheses. Then press equal. And you get this time, you're going to get, now the nearest cent, so remember the nearest cent, that's decimal right here, so the 2's in the hundredths place, so since this is less than 5, the 2 stays 2. Okay, so my nearest cent is going to be 82 cents. So I'm going to get approximately equal to $26,159.82. Okay, now I want you to notice the more times it's being compounded, the more money you end up with. It's not much, but you do end up with more. So you see how only 2 times a year you get $26,121? Here you get $26,159 or $160. Okay, so $26,160. So the number of times, the more times it's being compounded per year, the more money you end up with. It's not great, but it is an increase. Okay, so when we do monthly, you should expect this to be more or less than monthly. So should this be less than the number of times being compounded monthly, or should this amount be more? Well, monthly, this is quarterly, so monthly, this number should be, the amount should be bigger than this amount. Okay, because this is only 4 times a year, whereas monthly is 12 times a year. So let's see what it is. So in C part, let's say it's compounded monthly. So C, monthly. Okay, compounded monthly. So this time n is 12. Everything else stays the same. So A equals 20,000, that's my principal, times 1 plus R is the rate, 0.045 remember, divided by n, which is 12 this time, raised to the nt power, so that's 12 times 6. So putting that in your calculator, we're going to get 20,000 times, in parentheses, 1 plus 0.045 divided by 12, close the parentheses, then raised to the 12 times 6 power, close the parentheses, equals, and notice this time I get $26,186. And now remember, nearest census is in the hundredth place, but we've got to look at the thousands. Since this is less than 5, this stays at 6. So I'm going to get approximately equal to $26,186.06. So again, notice the more times it's being compounded, the more money you end up with. Okay, so remember, 4 months was this, so $26,159, and 12 months is this. Okay, so when n is 4, you get this. When n is 12, you get this. So it's being compounded. The more times being compounded, the more money you end up with. It's not a lot more, but it is an increase. So let's talk about now compounded continuously. Compounded continuously. All right, continuously. So continuously is an infinite number of times. So since it's an infinite number of times, since I'm looking at compounding continuously, I'm going to have to use this formula. A equals P times e to the RT power. So I must use A equals P times e to the RT. Okay? So the principle is still the same, so P is still 20,000, R is still 0.045, and T is still 6. Okay? The only thing you don't see is that n. So n is the number of times being compounded per year. So that's a finite number. Compounded continuously, n is an infinite number. Okay? So that's where that e comes from. Remember that formula we said 1 plus 1 over n? As n, raised to the n power, as n gets larger, right here. So remember that as n gets larger, this goes to e. Okay, so that's part of this right here. So this right here is part of this. All right. So we get A equals 20,000 times E in parentheses raised to the 0.045 times T, and T is 6. So notice that you really need a parentheses now because you do have a decimal. Now don't forget you are dealing with E, so make sure you use your calculator's E. Now also, you remember we said that E is approximately 2.718. Sometimes they'll approximate, and that's to the nearest 1,000. To the nearest 100, sometimes we'll say 2.712 to the nearest 100. So don't forget, to the nearest 100, this is what E equals to, 2.712. You round it off, okay, 2 decimal places. So since this thousandths place is 5 or bigger, the 1 becomes a 2. So to the nearest 100, this is E, 2.712, approximately equal to this. Okay, to the nearest 1,000, it's 2.718, approximately equal to 2.718. Okay, but we're going to go ahead and use the calculator Z and not any approximation. Use the calculator Z. It's more accurate if you use the calculator Z. So 20,000 times E, so e to the x, okay, raised to the, in parentheses, 0.045 times 6, close the parentheses, and then press, I'm going to have to clear this, okay, and then press equal, and you get this. So you get $26,199, and then remember, 8's in the hundreds place. We got to look at this since it says 5 or bigger. Since 9 is bigger than equal to 5, I got to add 1 to the 8, so I get 29 cents. All right, so notice compounding continuously gives you more money. Okay, all right, so that's going to take care of the interest formula. It's a very simple. Now let's look at this. Still dealing with compound compound interest. Let's look at number 2. Let's see how they want you to round off. Okay, so it'll be fine. Okay, suppose that you have $12,000 to invest. Which investment yields a greater return in 3 years? 7% compounded monthly or 6.85% compounded continuously? Okay? All right. Now, be careful. Don't say compounded continuously because continuously earns more money than monthly. Notice the interest rates are different. All right, so you got to look at the interest rates as well. Okay, so let's look at this. So compounded monthly, we're going to use this formula. So A equals P times 1 plus R over N raised to the NT. All right, so in this case, P is $12,000. So A equals 12,000 times 1 plus the rate for compounded monthly. Now be careful, this is continuously. You want compounded monthly. So 7% is 0.0. Remember 7% with the decimal point 2 places. Remember, it's to be here, so 2 places to the left. So it's 0.07. So 0.07 divided by N, monthly. N is 12. Remember, monthly, N is 12 for monthly. Okay, N is 12. Divided by 12, all raised to the N, 12, times T, and you were told this is 3 years. Okay, so approximate that. Let's see what we get. So 12,000 times, in parentheses, 1 plus 7%, 0.07, divided by, this was monthly, so divided by 12, close the parentheses, and now we're going to raise it to the 12 times 3 power, so 12 times 3, close the parentheses, and then press equal, and you get $14,795.11. Since remember this is your hundredths place, your cents. Remember cents near a cent means hundredths place. Since this is 5 or bigger, the 0 becomes a 1. So I'm going to get $14,795.11. Okay, so that's what I get for 7% compounded monthly. Now for 6.85% compounded continuously, since it's continuously, I got to use this formula. A equals P times E to the RT. So the rate now is 6.85. So remember 6.85%, you move your decimal point 2 places to the left, so it becomes 0.0685. Okay, that's what that becomes. So I'm going to get A equals 12,000 times E in parentheses this number, 0.0685 times T, which is 3 years. Okay, now I'm approximating this. Let's see what we get. 12,000 times E. Okay, 12,000 times E raised to the 0.0685 times 3. Close the parentheses. And let's see what we get. We got $14,737.67. Alright, so remember this is a hundredths place. That second 6 is the hundredths place. I gotta look at this thousandths place. Since this is 7, which is bigger than 5, bigger than or equal to 5, I gotta add 1 to 6, and you get it 67. So notice that this is so at 6.85% compounded continuously, I get $14,737, whereas at monthly, I get this. So to answer the question, which yields a greater return over 3 years, the answer is going to be compounded monthly. So the answer, compounded monthly at 7%. Okay. All right. So we did say earlier that the more times it's being compounded, the more money you get. But that's assuming the interest rate's the same. See, these interest rates are different here. So this will earn you more money, 7% compounded monthly versus 6.85% compounded continuously. Okay. All right. Number 3. Okay, so this formula, S equals C times 1 plus R raised to the T power, models inflation, where C is the value today R is the annual inflation rate, and it's written in decimal form, and S is the inflated value T years from now. Okay, if the inflation rate is 3%, how much will a house now worth $110,000 be worth in 8 years? And then round to the nearest dollar. Okay? All right. So remember, S is the inflated value T years from now. So that's what you're looking for. You're looking for S. C is the value today. So that's what that's $110,000 is. So we're going to get S equals $110,000 times 1 plus R. R is the annual interest rate, inflation rate, which is 3%. So as a decimal, that's 0.03. Raised to the T power. So T is years from now. So this is 8 years from now. So T is 8. And so use your calculator to figure out what this is. That's all you do. So you get $110,000 times, in parentheses, 1 plus 0.03, raised, close the parentheses, and then raised to the 8th power, equal, and you get $139, oops, $139,000, 344. Okay, so it says the nearest dollar, so let me go ahead and write what you see. So what you see is this. So let's go ahead and talk about that. 44.709. Okay, to the nearest dollar. Let me explain what the nearest dollar means. So the nearest dollar means the nearest whole number. Whole number. Okay, which is the nearest tenth. I'm sorry, the nearest ones place, excuse me. The nearest ones place. So basically, you're going to round off here to the ones place. So if this number, the tenths place, is 5 or bigger, then this becomes a 5. If this is less than 5, this stays a 4. Well, since this is a 7, which is bigger than or equal to 5, then this becomes a 5. Okay? So to the nearest dollar, the answer is 139,345. So $139 and $139,000. $345. Okay? So $139,345. $139,345. So that's the nearest dollar. Okay, so remember how to deal with the nearest dollar. So that's the nearest whole number, which is round to the nearest ones place. Okay, so around here, since this is 5 or bigger, this becomes a 5. 4 plus 1 is 5. If this was less than 5, like 4, 3, 2, 1, 0, then this would stay a 4. Okay, so that was number 3. All right, number 4. This is number 4. Okay, this is what you have. You have India is currently one of the world's fastest growing countries. By 2040, the population of India will be larger than the population of China. And by 2050, nearly 1/3 of the world's population will live in these two countries. The exponential function, and here's the exponential function, f of x equals 574 times, in parentheses, 1.026 raised to the x power, models the population of India in millions x years after 1974. Okay, so part A. Substitute 0 for x. So remember, x is the number of years after 1974. So we're talking about 0 years after 1974, so meaning 1974. So you see how we're talking about x's number of years after 1974? So if x is 0, that means 1974. Okay, so substitute 0 for x, and without using a calculator, find India's population in 1974. So we're going to plug 0 for x. So here's what you're going to get. You're going to get, use a different color. So you're going to get f of 0. Because remember, that's f of x. F of 0 equals 574 times 1.026 raised to the x power, and remember, x is 0. Okay, so without using the calculator, you got to remember this. Any number, any non-zero number raised to 0 power is 1. So this is 1 right here. This is the number 1 right here. And 574 times 1 is 574. Okay, so remember what that means, though. Remember, this function is in millions. Where was this? Right here, in millions. So this means 574 million people lived in India in 1974. So 574 million people lived in India in 1974. So that's a population of India in 1974. That's what you just found. Okay. All right. So now we're looking at, all right, so 27 years from now, from 1974, excuse me, 27 years from 1974, and that's going to be to the year 2001. So if you take 1974, and add instead of 27 to it, you get 2001. So in 2001, what was the approximate population of India in millions? Okay, so f of 27. So remember, x is number of years from 1974, so that's 27. Will equal 574 times 1.026 raised to the x power. So x here is 27. Now you have to use a calculator with this. So you're going to say 574 times, in parentheses, 1.026, close the parentheses, raise to the 27 power, and you get this. You get to the nearest, now set to the nearest, where do we see this? Okay, so where was this? It said, I forgot where I saw it. Oh, that was another problem, wasn't it? Okay. All right, so in millions. Okay, so what we're going to do here is we're going to round this to nearest whole number. So 1147. So let's talk about what that is. 1147. All right, so you're going to say, so that's going to be approximately equal to 11448 rather. Okay, so round up to nearest whole number. Since this is 5 or bigger, this 7 becomes an 8. Okay, so you're going to say that million. Okay, so 1148 million. Okay, now let's explain what this is, though. All right, so it's easy to see this 574 million in words really means this. Okay, so it really means this, 574, and then when you think about 1 million, how many zeros are behind the number 1? Well, there are 6 zeros, so you get 1, 2, 3, 4, 5, 6. So you see that this is 500, that should be 74. Do you see that's 574 million? Okay, so the same thing here. So it kind of looks weird to say 1,148 million. Really, it looks like this: 1148 and then 6 zeros. 1, 2, 3, 4, 5, 6. 1, 2, sorry, right here. So really, this is 1 billion. So the population of India in the year 2001 was a little over a billion people. So 1,148 million people. Okay, so that's what that means. So 1,148 million people. Okay, in 2028, let's see what the population was. So you're going to say f of, all right, so you got to figure out what x is. Remember, x is the number of years after 1974. So you got to subtract, you got to figure out how many years is 2028 from 1974. So you're going to say 2028, just subtract them. 2028, subtract 1974, and you get 54 years. So you can say f of 54 equals 574 times 1.026 raised to the 54 power. And let's see what that is. So the nearest whole number, 574, close parentheses, 1.026, close parentheses, raised to the 54th power equals, so the nearest whole number, that's 229. Okay, since the tenth place is less than 5, this stays a 5. So 2295. So 2295 million. Okay, so that's the answer you would write, because it did say write the answer in millions, in the word million, so then you'd write that. So 2,295 million, that's how you would say it. But let's see what that is. So it's really this, 2295 and then 6 zeros. Okay, so this really is 2,295,000, I'm sorry, 2,295,000,000 people. Okay, so it's a little over 2 billion people. So 2,295 million people. Okay. In the year 2055, let's see what we get. So subtract, find out x. So x will equal 2055, subtract 1974. So 2055 minus 1974 equal, that's 81. So we're going to find f of 81, and we're going to say 574, that's a 74, times 1.026 raised to 81 power, and so let's see what that is. So 574 times 1.026 close raised to the 81 power, 81st power, and you get 4590. So 4590 million, which is really this, 4590 and then 3 zeros, 6 zeros rather. So it's a little over 4 billion people. Okay. All right, and then it's asking what appears to be happening to India's population every 27 years. So you see 27 plus 27 is 54, and then 54 plus another 27, is that 81? Yeah, 81. So every 27 years, what appears to be happening to the population? So if you look at this is over 1 billion, this is over 2 billion, this is over 4 billion. So what they want you to say here is that it appears to be doubling. Every 27 years, the population of India is doubling. So when I double this, I get something close to this, 2 billion. When I double something a little over 2 billion, I get something a little over 4 billion. Okay, so it appears to be doubling every, so it doubles every 27 years. Okay? All right, so that I think takes care of all of the lessons, the 4 parts of the exponential functions, and so this part was on application. Okay, so make sure you can work out these use these formulas. You don't have to memorize them, just make sure you can use them. Okay, so that's going to take care of this part of exponential functions.